given a circuit here, and we're asked to find the Norton equivalent circuit. And to do that, there are 7 steps that we need to do in a particular order. The first step is to short circuit the load. So the load would be connected between points A and B, and the first step is to short circuit the load. So we connect A and B, bringing these 2 resistors in parallel. And what we then try to find is the current that's passing through that short circuit. So to do that, here we have a current source and a voltage source. It would help if they were both current sources. So one thing we can do is to convert this voltage source into a current source. Okay, so we've done step 1. In order to do step 2, I'm going to convert this source. And to do that, I'm going to divide the voltage divided by the resistance to find my equivalent current. So that is my 3 amp source. So this is my converted source, and this resistor is unchanged. Now it's still a little bit tricky finding the current passing through the short-circuited load. So what you can do is, when you have 2 current sources in parallel, simply add the currents together. And they're in opposite directions, so you have the total current will be 18 subtract 3. So that's 15 milliamps. And we have this 12K resistor in parallel with a 60K resistor, and that gives us an equivalent 10K resistance. So now we can redraw the circuit with our 10K resistance there and our 15 milliamp current source there. So that's the 15 milliamps, and that's the 10K resistance. So now we have the current source. It's easier to find this current because you have a current that's split between 2 resistances, so you can use the current divider. You can say the Norton equivalent current here, IN, is equal to the 15 milliamps multiplied by this resistance divided by the sum of these 2 resistances. So that gives you 6 milliamps. So now we found IN, we need to find the equivalent Norton resistance. And to do that, there are 1, 2, 3, 4 steps. So you open circuit the load, so you remove this short circuit, you remove your sources, and you find the equivalent resistance. So here I've done that. I've short-circuited the voltage source here and open circuit the current source, and I've removed the short circuit that I had across the load. Now we need to calculate the equivalent resistance. So it looks like these 2 resistances are now connected in parallel in series with a 15K resistance. So you've got parallel and series. These 2 give you 10. 10 plus 15 is 25. So now we found Rn. The last step is just to redraw the circuit with IN and Rn. So this is really your final step. You leave your terminals open. So this is where you would connect your load. You put in a current source with your IN. in parallel with a resistance of value Rn. And this is your Norton equivalent circuit.